All right. All right, so when we're solving this, okay, not really so much when graphing, but when we solve this, a system, using substitution or elimination, what can happen is this. You can get a statement that doesn't make sense, a false statement that is. 0 equals a non-zero constant. You can get that. Like 0 equals 1 or 0 equals 2, or you can get something similar to it, like 1 equals 2 or 5 equals 8, 10 equals 5. Well, those statements don't make sense, right? And there's no variable in it. So in that case, we say there are no solutions if you get a statement like that. So in that case, we say there are no solutions. However, if when solving it, you get a statement like this, a statement that's true, there are also no variables, then we say there are infinitely many solutions. So in that case, we say there are infinitely many. So let me say it again. If you get a statement that's true, like 0 equals 0, 1 equals 1, 5 equals 5, and there's no variables there, then we say there are infinitely many solutions in that case. Again, that's just what we say. All right, that's cool. Well, let's dive right in. So what I'm going to do here is I'm going to solve this using substitution. Then you'll see after this, I present the method. I did email everyone the notes. So you should have the notes, in your email inbox. All right, so let's actually solve this. I mean, we found a solution, right? We did find one already. But remember, that's not enough. We're not done, because how do we know there's not infinitely many? Well, that's why that's why we have to solve it. Okay. Well, from the first equation, right, what I can do, I can get y in terms of x. Okay? I can get y in terms of x. Now, why am I getting y in terms of x? In other words, why am I solving for y in terms of x? Well, notice the coefficient of y is it's a -1 because we have a subtraction here. But if it's a 1 or -1, I would solve for that variable in terms of the other. I mean, is that always going to work? I want to say no, but it's a very good attempt at least. Most of the time it will work, most of the time. But can I guarantee you it's always going to work? I can't guarantee that, no. Okay, so from here, we get 2x minus y equals 5. So I'm going to get y in terms of x. So what I'm going to do is subtract 2 times x from both sides. And so from here, negative y, right? We get negative y. So what I'm going to do here is subtract 2x from both sides. We get negative y is this. So negative y is 5 minus 2x. All right, that's great. But we don't want negative y, right? We want y. Okay, so let's do it. Well, we want to get rid of the negative sign. Well, let's divide both sides by -1. Doing so, dividing, we get negative y over -1. Well, the negatives cancel, you just get y. And so we get y equals this. Like so. Right? So we're dividing by -1. We get -5. Negative becomes plus. So we get y is -5 plus 2x, which is the same thing as saying 2x minus 5. So we get y is 2x minus 5. Okay. Good. So we have y in terms of x. Well, okay, so that's great. What can we do next? Well, we have the other equation there, don't we? We have the x plus 2y is 5. We didn't use it. We didn't use that equation. Well, let's use it. Using it, since we know what y is in terms of x, right? We could plug it in, like I'm doing here. So in other words, in the second equation, I replace y with what we have, okay? And we get x plus 2y is x plus 2 times 2x minus 5. And that's equal to 5. So that's what we get here. That's great, because what happens next? Well, notice we can distribute 2, right? We can distribute the 2. So basically here what happened is we now have an equation in one variable only, namely x. Namely x. Okay, well that's great. So big deal. How does that help us? Well, let's now solve for x, right? So basically by substituting for y, the expression we got, we essentially took away the variable y, and we have an equation in only one variable, x. So we get x plus 2 times 2x minus 5 is 5. That's what we get. Right? So we only have one equation in one variable. Let's solve it like we would in chapter 1. So distributing, right? We want to get x all alone. So we have x plus 2 times 2x minus 2 times 5 is 5. And so that gives us x plus 4x minus 10 is 5. So we get 5x minus 10 is 5, right? Now we want to isolate x, right? We want to get x all alone on one side. That's what we did in chapter 1. So we get x now. So adding 10 to each side, we get 5x is 15. Dividing both sides by 5. As you can see, we get x equals 15 over 5, which is 3. Yahoo, we're done, right? Well, almost. We know what x is, but what's y? We have to get that, right? So we know x is 3. Y we have is 2 times x minus 5, which is 2 times 3 minus 5, right? We know what x is. Well, we know what y is in terms of x. Well, let's replace x with what we got. We get y is 2 times 3 minus 5, 6 minus 5, which is 1. So that's what we get here. So what we get then is that x is 3. Using this expression for y in terms of x, which we got, we get y, which is 1. So our unique solution is 3, 1. So now we know for sure there's only one solution, a unique solution. And using our terminology, we get then that these equations here are independent. As you can see. Awesome. Okay. Now, what we just did was the substitution method, right? Basically, what we did was we used one of the equations to get one variable in terms of the other, right? We used the first equation to get y in terms of x. That's what we did. We substituted that expression into the other equation, right? That's what we did here. Doing so, we essentially killed off a variable. That is, we ended up with an equation in one variable only, as you can see. right? We solve that equation, and once you solve that, the number, whatever you get, you plug in to the expression you got in one. You know, you got one variable in terms of the other, you plug it in. And then you just check by substituting. So again, when you solve it, in step 3, you know, if you get a number, right, you substitute into the expression you got where one variable is in terms of the other. You know, that's what we did. We plugged it back in to the expression to get the other variable. Right? And that gives us the answer. And you know, you check by substituting. Keep in mind, again, we'll see some examples, but if we got something like 0 equals 1, that would tell us no solutions. Or if we got something like 0 equals 0 or 1 equals 1, then we would have infinitely many.